Welcome to this presentation on battery temperature and state of charge monitoring system using the ESP32 microcontroller. In this project, the ESP32 is used to monitor important battery parameters such as voltage, temperature, and state of charge. State of charge, I mean SOC. So, SOC represents how much charge is left over in the battery that can be utilized in a proper way in our EV application for driving the vehicle. How much power is remaining? So that is represented by SOC. This being the first project in ESP32, we will use a simple design just to monitor the SOC. So students who are interested in taking this work as a project, you can also extend it by adding IoT based monitoring. So therein you will upload the data which are available in the ESP32 into the cloud. That way you can add IoT features to this project. So it is a IoT ready project. You can display, you can view the data in serial port, and this is some sort of data acquisition and processing based on ESP32. So coming to the next slide, the main objective is this: you measure the battery voltage and temperature continuously. So it again it estimates the state of charge and detects abnormal conditions such as over temperature. So this provides the foundation for BMS monitoring, data logging, and IoT connectivity. So that is the aim of this work. So this is the overall block diagram of the system. So here you have a battery that will measure the voltage using voltage sensing circuit. Then you have a temperature sensor. Actually it is a temperature sensor IC. So directly the output of the temperature sensor is connected to the ESP32. So the pin which connects the temperature sensor with the ESP32, it is called ADC pin. It is also one among the general purpose IO pin. So the IO pin with analog interface facility or analog that can read analog inputs. So that is the place where the temperature sensor output is connected, and the coding written inside ESP32 that will perform the SOC estimation. So that we will write the coding for that SOC estimation, and you can also add some more things in the block diagram, such as you can add the LCD display or Wi-Fi dashboard, or if you want current sensors also you can add how much current is flowing into the battery. That also if you want you can add. So here we have shown only voltage monitoring alone we have shown. So the ESP32 it is the monitoring system. It is suitable for real-time measurements and control. It has got multiple ADC pins. If you see the architecture of the ESP32, the general purpose IO pins are there, and many ADC pins are there. At least 12 different ADC pins are available. As you know, ESP32 it is 32-bit processor. The major advantage of using ESP32 is that it has got built-in Wi-Fi and Bluetooth capability. That is the reason why we migrate from Arduino to ESP32. In addition to local monitoring of the battery, you can also transmit the data into computers or mobile applications or IoT dashboards. So these things can be done with ESP32. For temperature measurement, as we told already, it is a IC. There is one more option. You can use NTC thermistors also, or some other ICs such as the DS18820 or other ICs you can use for temperature sensor. The sensor should be thermally coupled to the battery outer surface or the cell surface. We mean the cell. Cell we refer to the individual unit. The whole setup, it is the battery. One individual element inside the battery is called as cell. The ESP32 reads the sensor, that is the DS18820 sensor, and it will display the temperature. If the temperature exceeds the predefined value, the system can generate a alarm indicating that there is a temperature related fault. So temperature limits for any type of battery you should select from the battery manufacturer specifications. The battery voltage must be scaled in such a way that it is within the ADC input range. As we told just now, the battery voltage measurement, it is done using the ESP32. So batteries may operate at 60 or 70 volt, whereas the ESP32 works in 3.3 volt. So what level of ADC input the ESP32 can hold, to that level you should reduce the voltage by using voltage dividers. That reduced voltage, that should be connected to the ADC input pin. So for that the formula also is given, how to calculate the voltage divider or the protection resistor, that is given here. So it's just a mere voltage division that you can easily design. In the code, whatever value is read by the ADC, that you can convert it back to the range of 0 to 48 volt or 0 to 68 volt. So that conversion will be done by the firmware which is put inside the ESP controller. For multi cell packs, using an appropriate battery monitoring AF, and do not connect the high voltage cells directly to the ESP32. This is one more precaution which you need to follow. Now we come to the state estimation, that is the battery state of charge estimation. State of charge, it is commonly called as SOC. As I told, it is the amount of charge remaining in the battery. For example, if you are saying that SOC is 100%, means the battery is fully charged. Likewise, if the battery is 0%, it means that the battery is in empty condition. So this is a simple way to estimate the SOC of, or to interrupt the